Hello and welcome back to my Ravemachine build series. In this video we will install the electronics, solder everything together and prepare it for final assembly. First things first, we have to get the microcontroller going. So on this ESP32 you should install WLED. I will show the link on screen and in the description. You should install the sound reactive version so that you can have sound reactive lights on your speaker. We have to solder some stuff onto it. We have to install these resistors. These are two 100 kilo ohm and two 220 ohm resistors. Then we have to attach some cables and some other stuff so that it works. So first we will solder on some resistors. We will start with the 100 kilo ohm resistors and we have to put pin number 12, that is right over here, on half of the 3.3 voltage. So we will put one resistor from 3.3 volt to the D12 pin, and then we will connect the ground with the resistor to this pin as well. Now we have to connect the 100 nanofarad or larger capacitor to the audio input for DC and AC, like AC coupling and DC decoupling. Next, we will connect the resistors for the LED outputs. So between the LEDs and the data output of the ESP, there should be resistors, so the LEDs will last longer because the input register will have less current flowing through it and will therefore burn out less quickly, especially when dealing with fast response rates. We will connect those resistors to D2 and D16. These two resistors are now connected to D2 and D16 and will be used for connecting the LEDs in a second. Now we have to take a piece of the cable that we have left over from one of our speaker assemblies and cut off a piece. So, like that. And then we need like another piece that is probably around that long. And then we cut another piece with the same length. And then we check our leftovers and see, okay, we already have some of those of this wire left as well, so I just take some of those leftovers as well. So what we need now is we need power and we need the connections to the LEDs. So for that, put this to the side. First we connect power. So this will go to the step down converter to provide 5 volts. We have we have to connect this to the voltage input. So on this side here are 2 pins labeled V in and ground. V in is the positive and ground is the negative. So now we have power connected to our ESP and it will just go like this. Now we put this to the side for now. We still have to connect the LED adapters and the button for changing modes. But for now, we continue with the next part. So now we will take a step down converter and connect the input side to one of those cables that we just prepared. Now that we've connected this to the step-down converter, we will use our power delivery board as a voltage source, so we can adjust the output voltage of the step-down converter to 4.7 volts. Why 4.7 volts? The WS2812 LEDs that we use are 5 volt LEDs, but they also use a logic level input. So they use 0.7 times the supply voltage as an input voltage. We only have a 3.3 volt microcontroller. So the problem is the microcontroller's output voltage is lower than the high logic level of the LEDs. To circumvent that, we will just lower the input voltage a bit so it's closer and it will work then. So if you're having problems with the LEDs flickering or not responding right, just lower the input voltage. You can go down to about 4 volts, but we can only go down to 4.3 volts in this case because the DC-DC converter on the microcontroller itself can only go down to that level as the input voltage. So we will set it to 4.7 and save some energy and don't have the problem of the voltage conversion or a logic level shifter. Now we connected the step-down converter to the power delivery board. We can use this chance to also set the voltage of the power delivery board so it always requests the highest voltage available and delivers the maximum power. I will use this power delivery laptop charger to get 20 volts from USB-C. You have to be aware that you have to use a power supply at least once when you set the voltage, so that you can adjust the right input and get the right amount of power. So as we stick it in, you see the LEDs are blinking, and now in my case the 20 volts lights up. If you hold down the button, it starts blinking again, and then you can choose by pressing what voltage level you want. We want the highest one, so we set it to all LEDs blinking and then just wait until it accepts it, and now we have 20 volts going through to our step-down converter. Now we need some device to measure the voltage. I will just take my multimeter here and connect it to the step-down converter. And now I adjust it so it will deliver 4.7 volts. That should be alright. Now the voltage is set right for this step-down converter, and we can continue with our installation. We can put the multimeter on the side for now. Now it is time to assemble the front. So we already glued in the diffuser before, so it should look like this. And be ready to install all the other things. For that we need like almost every cable and so on that we got from the functional cables kit. And then we take our USB-C and disconnect the step down. So let's start. You can of course put those things in however you want, so please don't comment, oh it's the wrong way around, or I would have done it the other way. You can do it the other way, you can do it however you like, it's your project. Feel free to configure the front as you wish. There are multiple options to like for the LEDs of for example how they work. I will get to that in a bit later, but you can think about what you want your LEDs to show, how like how they're arranged and everything. So this is the volume control, the on-off switch, and now we continue with the LEDs. The one with the red cable is also the red LED. I will use this one to show that it's still charging. So if my device is plugged into USB-C, it will show me that the battery isn't yet full. I will put this on the right side because I like my things symmetric. So when I plug it in, this will be the power plugged in LED, so these both light up, and if it's asymmetric, you can take the USB-C out, and the middle will be the Bluetooth LED, so you can see if your Bluetooth connection is good and if it's connected or if it's like pairing or whatever. So now we have connected all the LEDs. It should look like this from the front. So they're all they don't have a color when they're off. So I think it looks pretty nice. And we continue with the aux, the button for the LED lights, or you can also use it for something different, or and the USB-C charger. Now we need to install the USB-C power delivery board. If you take it and flip it upside down, it should just fit in there. Just like this. And to secure it, we take this little piece and an M3 screw to lock down the USB-C connector to the front. And just like that, the USB-C board is secured. Small tip, if you thread in the screw first and then take it out again and then install the board, you will have an easier time finding the thread with the screw. So this is the front, all done. Now we have to figure out where to put our electronics. For that we go back to our step down converter. We have the input and the output will be connected to the cables we already have put on the ESP, but those are too long. So now we have to see where we can put them. Now is also the time to check the clearance of the pins of the ESP. Some of those are a bit longer, some of those are a bit shorter, and the clearance between this backside and the battery pack is not that big, so you may have to shorten those pins of the ESP. In my case, the pins will stand out a bit, so I will shorten them a bit, so it will not get in contact with the cells. So now I have shortened those pins a bit and we can continue with the installation. Oh, I will screw this in place with 2 screws for now. You can add the other ones if you want, but like they say, I don't think it's going anywhere, so... So now we can see how much length we need for the DC-DC converter. So it will be right around here. So now that we've got that, we can solder the last 2 wires to the DC-DC and screw that in as well. Now these two components are screwed in place. What do we have here? We have the outputs for the LEDs, and we have the input for the music. That's the next thing we're gonna address. So, if you look at your amplifier, you've got to notice this output. It's called a mixed out. So we're gonna use that. The ground is the same ground as the power supply ground. I measured that out, so we don't need that one, we just need this mixed out. In the functional cables kit, there's this cable where it just has this 2-pin connector and then 2 open ends. We plug this in here, and then we take our mixed out, and first we're gonna see how much of it we actually need. So if we place it where it should go, it's like that much. So don't make it too long because it will already be a mess in there. So just cut it short. And the other one we can like cut really short so that we don't mess up our wiring. Now we've got the audio inputs figured out. We have to address the powers, like the power to the LEDs. The LEDs for the sides will be wired in parallel, and the one for the front will have a single output. So we're taking these resistors and cutting the ends short, just like this. So now it should, like, the wire for the audio is in the front and the 2 resistors are here in the back. So now we take those 2 adapters and the wire we already cut before, and now we have to connect this all to the DC-DC converter. Take your time with these ones and really solder them properly, or your light show will maybe not work like as well as it should. So now we have to connect the data lines to the resistors. In this case, we have to connect both of the data lines of the connectors to D2, and the wire we have left from before to D16. Now we've connected that, we can screw in the amplifier board. So now that the amplifier is in place, we can plug in our first cable. Maybe put it under there. Then through there. Now we take those two wires for the LEDs, for the logo, and we just, twist them around a bit. And then we attach it to the LED module. Be careful that you wire it on the right side, so there is one side that it says DI, so that's the input, and the other side would be the output, but we don't need that. So next we will switch back to our front. Our front side now has a lot of cables on it, and we need to attach some more stuff. Next we gonna stick on the Bluetooth antenna, just like this. And now we need to figure out the power supply. So we've got our main switch right here. Power input to the switch will be on the top, and power output will be on the bottom. This is the point where we will connect those two parts, so they will be together for now and cannot be separated more than they are now. We need power input for our step-down converter, and we need power input for our amplifier. As this cable is too long and we don't want that wiring mess, we can just plug it in, just like that, and then see how much cable we actually need. So if we are generous, we need like this much cable. Should get us plenty of time and space. We need those later on in the video. Now we wire the power input to the speakers and the step-down converter to the bottom side of the switch. So this looks good. Now we need to figure out the power input. For that we have this cable. It will go from the back all the way to the front. It is still too long, so we can shorten it a bit, but not too much in this case. Better leave it a bit longer, or even the full length if you want to have more ease of access. So now we have these two wires, and we will use them to connect the top part of the switch. So now it should look like this. The top is connected to this cable, and the bottom is connected to the other cable. Now we need to figure out the rest of the power supply. Now we have to connect the negative of the step down, the negative of the speaker, and the negative of those two wires together. I will again use some heat shrink tubing to make it prettier. It might be a bit tricky to solder everything together, but in the end it should look like this. So you have the input going in and the two outputs going out. Now we can take the remaining cable that we got left from before and screw it into the DC, the USB-C input. Now that we've got this mess of wires, it's time to connect some of those. So, first we're gonna connect the power supply. This second power supply cable will go through the back here. The cable from the aux input will go right here. For this cable, you just plug it in as far left in this big connector as it can go. Next thing is the Bluetooth LED. The Bluetooth LED is this connector right next to the audio output connector. The other two LEDs, we will take the cables. And then we just put them back through there together with the power supply cables. So, the next thing would be the switch for the LED button. Now you can decide whether you can put this on the main board and make it like switch off Bluetooth or anything, or if you want to use it as an LED indicator button, like as an changing mode and whatever button. So I will do that. So I will just cut the cable and use this button as a pull down button for my microcontroller. For the button, you can almost use any button that you like and any pin you want. I will probably use some of those on this side, so I will just like connect it to D25, for example. And the other side of the button I will connect to ground. Now this is connected. Now we can connect the antenna cable. Now we have to see how this all works out. So we have the two LEDs for the sides. We have the LED for the front. We can mount that in a second. And then we have the antenna cable left, and we have the cables for the BMS. And one cable is still missing, I just noticed. This honking cable that is going to our potentiometer for our volume control. You just have to pull out those small tabs on this connector. And then plug in the big cable. And now we can plug in the antenna cable, but maybe I will do that later because it's a bit more sensitive than the other cables. So now we can clean up this mess a bit. And then I zip tie everything together. So now the last thing missing is to mount the LED to the front. What have we done now? We have almost completely assembled the insides of the speaker. We have connected all the parts in the front. We have got the LEDs, we have got the speakers, like the amplifier, we've got the ESP with WLED on it, and we have the power supply. So in the next video I will finish the assembly, put in the batteries and the BMS and screw everything to the speakers, and then it's finished. You should be able to listen to music. I know it's a lot of work, but stay on it. You can do it. I can do it. See you in the next video. Goodbye.